Okay, so picking up where we left off. In this part of the lesson, I'm going to talk about something called end behavior of a function. So the end behavior of a function's graph is the behavior of the graph as x approaches positive infinity or negative infinity. So basically what I'm talking about is a graph is just a snapshot of a function. There is no way we can show an entire function. The function goes to infinity, or the graph goes to infinity in basically all directions. So as we go to the right, towards infinity to the right, does the graph go up or does it go down, or does it approach a number? For negative infinity, as the graph goes to the left, does it go up towards infinity? Does it go down towards negative infinity as far as the y values go? So for the graph of a polynomial function, the end behavior is determined by the function's degree. And that's why I was so psycho in the last video about degree. Also, the leading coefficient is another important thing. So knowing that vocabulary is going to be important for describing end behavior. And if you can describe end behavior, that's like the early stages of understanding some calculus. So it's a big concept. So when we talk about end behavior, this is this top left box. When the degree is odd and the leading coefficient is positive, a function will have this general end behavior. As we go to the right, as we go to positive infinity, as x goes to positive infinity, that means to the right, our function goes up. Our y values increase to positive infinity. Okay? As we go to the left, as our x values go to the left, our y values go to negative infinity. So this f of x means y values. So positive infinity for f of x means up. Negative infinity for f of x means down. For x, that represents left or right. X goes to positive infinity means to the right. X goes to negative infinity means to the left. So we're going to see patterns as we go along, but this is going to be difficult at first. So if the degree is odd and the leading coefficient is negative, our function goes up to the left, down to the right. So reading this is going to be important. You've got to be able to visualize what that means and describe what that means. Okay? The main thing is that with odd functions, you're going to notice with odd functions always, as we go to the right, it goes a certain way. As we go to the left, it goes the opposite way. So odd functions have opposite end behaviors. They don't both go up. So we're going to see that in even functions. They either both go up or they both go down. As we go to the left, go to the right. So this is going to sound kind of weird right now, but as we see more functions, I think it's hopefully going to make more sense. So let's go down to even functions. With an even function, if the degree is even and the leading coefficient is positive, it goes up to the right and up to the left. It has the same end behavior on both sides. Okay? If the degree is even, but the leading coefficient is negative, it has the same end behavior on both sides, but it goes down to the right, down to the left. Okay? So I want to show some examples of this. This diagram right here, this box, is going to be, I think, extremely helpful later on when we start to see more of this. So keep that in mind. So in example 3, describing end behavior. The things we have to notice: the degree is 4. That means our degree is even. Our leading coefficient is negative 0.5. So when we look at this big box here, our function has a degree that is even and a leading coefficient that is negative. So I'm going to circle the one that this is right here. That's the one. So what we've got to be able to describe, I'm going to get rid of that. What we need to be able to describe, our function is going to look something like this, where eventually it's going to go down to the left and down to the right. So describing the end behavior, the first thing I'm going to describe, as x goes to positive infinity, meaning as our function goes to the right, f of x, our outputs, our y values, as we go to the right, those y values are going to negative infinity. Our y values are going down to negative infinity. So this x goes to infinity means to the right. F of x going to negative infinity means it's going down. Now, we talk about the same thing as x goes to negative infinity, meaning as x goes to the left. Our outputs, our y values, also go to negative infinity. Okay? Remember, even degree functions have the same end behavior to the right and to the left. Okay? So that's the thing we've got to kind of get down. Knowing when I say x goes to this, f of x goes to this, what does that mean? Okay? So in the guided practice, maybe pause the video and try that one on your own, and then I'll kind of describe it. But it helps to write the degree and leading coefficient. Okay, so for the guided practice, for this, the degree of this function is 3, so it's got an odd degree. The leading coefficient is 0.25, meaning that it is positive. So if we go back to the top, we look for odd degree, positive leading coefficient. That means our function is going to look something like this. So if we look at that function, as x goes to positive infinity, meaning as x goes to the right, think about our outputs, our y values. Are our y values going up or are they going down? In this case, they are going up. As x goes to the right, y values go up to infinity. As our x values go to negative infinity, meaning as we go to the left, what is happening to our y values? Well, our y values are going down, meaning they are going towards negative infinity. That is what I want you guys to understand, okay? That is an important thing. End behavior is an important thing because we're describing graphs, okay? Describing graphs, being analytical about graphs is going to be an important skill. For a second, if you have to go back and look at this table to help you remember, please do that. So, the next thing, we're just going to get the early stages of graphing. Now, I'm probably not going to do example 5, okay? I would do example 5 if we were in person, all right? But I don't think I can effectively explain that in one shot on a video. So I'm just going to go through example 4 and the guided practice for example 4. If you want me to explain example 5 to you, we can do a Google Meet or something like that, and I'll be happy to do that, but I just don't think I can do it properly just through a video, all right? And maybe that's me coming short as a teacher, but I want to make sure that I teach you stuff that I think you can understand, and it's not that you're dumb or anything, it's that I can't explain it well enough for somebody to understand, so I don't expect you to learn that way. So, example 4. Enough of my psychology lesson there about myself. Graphing polynomial functions. To graph a polynomial function, we're going to first plot points to determine the shape, and then we're going to use our end behavior to sketch the rest of it. So we're basically getting all the kind of some in-between points and then drawing our end behavior. So for this, pick values. It really doesn't matter which values you pick, as long as you pick x values that fall on the graph, obviously. I'm not going to pick -50 for an x value. So for me, it's not lazy to pick small values, to pick what I call, I don't like using the word easy, but easy numbers to evaluate. -2, -1, 0, 1, 2, right? And then it's you substituting in and getting outputs. So I'm going to do these, use a calculator, whatever you need to do. Eventually we're just going to use Desmos, but if I substitute in -2, I get out 3 for this function. I substitute in -1, I get out -4, and then I get -3, 0, -1. Now I know I came up with those really quick. That's because I did this ahead of time else this would have taken me like a minute to work through all this. So this is me doing the work of substituting in, so that doesn't show right there. But that's me getting outputs for the inputs. So I'm just going to first plot these points. -2, +3. -1, -4. 0, -3. 1, 0. 2, -1. So I've got kind of a lot of weird stuff going on. What I'm going to do is I am just going to draw a smooth curve through these points, but not go to the left of the leftmost point and not go to the right of the rightmost point. So that's just going to show this graph goes from the point on the left, goes down, hits this point, is going to have to rebound and come back up, is going to have to go through this point, is going to have to rebound and come back down. Now, you might just think, oh yeah, I can just keep going and draw my arrows. But I really want us to understand the end behavior. Degree of this is 3. Leading coefficient is -1. So this is going to be a function. If we go back to our table from before, it's going to be an odd function, an odd degree function with a negative leading coefficient, meaning it's going to have end behavior looking something like this. Okay? As x goes to positive infinity, this is going to go down with an arrow, okay? And then as x goes to negative infinity, meaning to the left, it's going to go, y values are going to go up to infinity. And now that logically may have made some sense because it looked like it was going that way anyways, but this end behavior is super important to know how to draw the general shape of a graph, all right? Because I am not looking for perfection. I am looking for you knowing how to determine end behavior and what that looks like in a graph. So this guided practice is an excellent chance for you to get practice graphing and just remembering that end behavior. If you have to go back, and I'm going to skip back, all right, please do that. So I'm going to take a few seconds to let you guys pause the video, and then I'll show you my solution once I'm ready to go. Okay, so for this function, I know -212 doesn't fit on our graph. That's okay. I'm just going to graph the ones that fit. So I did that, and then I used the fact that this has an even degree and a positive leading coefficient. So the end behavior is going to be the same, and it's going to be going up to the left, up to the right for our end behavior. So that looks like, if we just went by the points, it looks like that graph is just going to keep decreasing to the right. No, it's got that even degree. So it's remembering that end behavior, because that's what's deceiving, is that the graph just doesn't go the same direction the entire way. Polynomial functions do a lot of kind of funky things, but it's understanding that I made that mini sketch on the side here with this little W to show even degree, positive leading coefficient opens up. If this were a negative leading coefficient, this would open down. So now I'd say you're ready for the final, like, kind of piece of practice and then the checkpoint. So this is a big lesson. It's going to take a bit to get through, but like I said, a lot of information, a lot of new information. So soak it in, practice, ask for help, and move forward.